One of the main visual features of Crimson Desert is this. But what is this? And how could they use it everywhere? While a lot of players reported some flickering and visual glitches here and there, most environment artists and many other devs have been trying to put the finger on how Parallax did it. How could their engine get away with using this effect everywhere without crippling the performances? And I'm talking about running the game on a high-end PC that has no issues. This is not meant to start a debate around the base PS5 version and how come the game looks like this on this console and all that jazz. Let's keep our focus here. You can hear my assumption in this video that I made a few weeks ago. I was concluding that it was displacement with a distance from the camera system to turn it on and off. Many in the comment section suggested it was in fact Parallax Occlusion Mapping. But me and many other devs that I talked to and others online were not convinced. In my case, the specific reason I did not believe it was POM, or Parallax Occlusion Mapping, was that the silhouettes were not flat, like it's usually the case with POM. And here's another thing suggesting that it was not your standard Parallax Occlusion Mapping. While it's really cool to see the effect appear when reaching a certain distance, Parallax Occlusion Mapping, or let's call it POM, should not be visible in the depth buffer. It is rendered later on in the pipeline and would usually not be seen here at all. By the way, this is done using Reshade, which is a great tool, free and open source, that you can use if you run the game on your PC. Link will be in the description. For those who might not be familiar with these topics, let's say that displacement, which relies on vertices, so geometry, takes the information from a height map, and with the added geometry created by the tessellation, which is really like adding a lot of vertices, it then pushes in and out those vertices to create depth. Parallax Occlusion Mapping simulates displacement by shifting UV coordinates based on camera angle and height, and it does not add any geometry. That's why it's cutting straight at the edge. Regarding performance, displacement is usually more expensive because of the increased vertex count, while Parallax Occlusion Mapping is a pixel shader trick. It's considered moderately expensive, so less than displacement. Logically, that must be the technique Parallax chose, right? Seeing that it is everywhere and that the general performances of the game are stable. I mean, the FPS is holding up, right? Except this fact. POM doesn't do silhouette, and we can see the wall silhouettes on every wall corner in the game. So the mystery remained. And since Parallax did not officially reveal what techniques were used, we have been left to speculate. But some people are very curious and wanted to get to the bottom of this. In my first video on the game, the one about the engine, I mentioned the next dev from Parallax talking about the team being obsessed with optimization and that they were using very old techniques that are nowadays not forgotten but not common for modern games. So this gentleman, Georgian Avasilkutei, sorry if the pronunciation is incorrect, so he posted this on X. He says it appears to be parallax mapping with offset limiting, and it can easily be switched on and off. He also gave the link to a paper which is from the early 2000s, which I will get back to in a minute, and link in the description, of course. Another dev named Joshua Stubbles suggested that it was indeed what Parallax used for their game, and it was also called SPOM, or Silhouette Parallax Occlusion Mapping. So let's take a look at the magic trick. This is also an old document, but look at the issue with standard POM. So you got your normal mapping, which we're all used to. We learned that in schools. It's basically one of the first things we learn. But look at the edge of the wall with the parallax occlusion mapping, and you understand that it's quite limiting. And it's usually used for ground. So it's like a continuous surface on which you can put, of course, rocks, twigs, grass, absolutely anything. So it's really easy to fix this issue. But on walls, we have certain limitations. But then with the parallax occlusion mapping with silhouettes, or Silhouette Parallax Occlusion Mapping, this issue is gone and the cost remains reasonable. So this is another example where it does bricks very nicely, like we can see here. And this was used commonly, but we needed to add beams or columns to hide the hard edge of the flat geometry. But SPOM, or SILPOM for Silhouette Parallax Occlusion Mapping, seems to be solving this issue. I will add many links in the description so you can find a lot of reading material. There are some very intense definitions, but some of you might be interested in reading that. It's also interesting to see that Cryengine was using this technique more than 10 years ago. In case you were not aware, Cryengine is or was available for free, and before Unreal Engine 4 and 5, it was the next-gen engine that anyone could use. I remember using it a few times while in school 13 years ago, and back then we were using Unreal Engine 3. I know, I'm old, and I hated Unreal Engine at the time. It was clunky and ugly and had so many issues. Cryengine was so ahead of this. It was just a blast working with this engine. Anyways, I will put the link to the documentation from Cryengine that explains that SPOM is like using tessellation without actually being tessellated. You know, this kind of wizardry. And same thing for this video that shows this very technique, and you can see that it can very well be what Parallax has been using in their Blackspace engine. Also, it was possible to use this technique in Unreal Engine 4 in 2015. So it's really nothing new, and it's high-level optimization and shader trickery. You can see here that the movement that you see on the edge of the screen is typical of POM. Displacement does not do that. So it further proves, quote unquote, that this is what is being used here. So while many people playing the game are complaining about some weird visual flickering and glitches that annoys them, which is a legitimate complaint by the way, but most devs, especially artists like environment, texture, and tech artists, have been trying to crack the code since the game launched. We're trying to understand how is it possible. How is this game running smoothly with that level of displacement or POM all over? What kind of magic trick did Parallax pull? Note that all of this is still speculation at this point, but we are making very well-educated guesses at this point. The community is coming together to explore the technology behind this wonderful game. Just like those who have been playing or exploring the vast lands of this world, this game keeps us obsessed and is moving things forward. But here's the conclusion of this investigation so far. It really looks like the devs at Parallax have been using a very well optimized Silhouette Parallax Occlusion Mapping for most of their tileable materials. And the byproduct of that decision is some flickering here and there. I would say your experience will vary depending on your hardware. And we're talking about PC hardware here. And while this decision makes a lot of sense and actually explains a lot of things, it is also a source of division among the players. Some can live with the artifacts created by the use of this technique, while others see this as a cheap-looking glitch and they think it's poor optimization from the team. The least we can say is that this game is making a lot of noise in the industry, and looking at the sales numbers, which has been announced this week, 4 million copies sold, it's touching the gaming community and finding its audience. If you're learning from these videos but are still struggling to put everything together into a full environment, that's exactly why I built my full course. You'll build the entire scene step by step in real time, understanding composition, scale, materials, and lighting, so you can apply the same process to your own worlds. These environments were created by students using the same workflow you will learn here. It's designed for artists who already know the basics and want to create a professional portfolio work, not just isolated studies. This isn't about learning tools, it's about learning how professionals build environments. If that's where you're trying to get to, you can check the link in the description. And a quick thank you to the members supporting the channel. Your support helps make these videos possible.